Hello everyone, welcome to BS Explained. In this video, let's talk about what Modbus is, how to integrate Modbus into Niagara Workbench. Alright, let's get to the Niagara work. This is the sensor we're going to use for Modbus integration. So I can quickly show you what it has. You can see G0, G1 terminal, which says it is a 24 AC or DC, it accepts both, and you have A and B, which is a transmit and a receive terminals. So this will be your RS485 going into JACE or any controllers where you're bringing your Modbus network to. We'll be connecting the sensor to the JACE, which you see here, and as you can see, the JACE has a RS485A terminal with A plus, A minus, and a shield. So your TX and RX is going to be wired into these two terminals. Positive and relative does matter when it comes to Modbus. So I will show you further what TX or where TX goes to or RX goes to in the JACE, and let's see how we configure Modbus once you get into the JACE. What is Modbus? Let's dive into the topic of understanding what is Modbus, why do we need Modbus, and how to interact with Modbus if it is in your device. So Modbus is another protocol which is usually seen in the industrial automation rather than building automation, but it is a protocol which was brought from Modicon to integrate all the devices into a single platform instead of proprietary protocols which were being used in the industrial automation. So Modbus is another protocol where you talk to devices in a certain manner amongst different other manufacturers. So that's the basic of it. I'll not bog you down to the least details of what Modbus is, how it does, and whatnot. We'll just go on the surface to understand what we need for our integration with Niagara. Next, how can you access to Modbus, or how do you communicate to Modbus? Modbus usually can be communicated with two-wire RS485, which is usually known as Modbus RTU. You have your plant controller, have your 485 port, bring two-wire with a shield or just two wires to the device which has RTU capabilities, which is a Modbus device. The next thing can be a Modbus TCP, which is on a Cat5 or Cat6 communication. You put your Cat5 into the device, put it to a local LAN, and bring it to your controller where you're going to access this sensor data in your controller. Apart from these two, we do have Modbus ASCII and Modbus Plus. I specifically haven't worked with Modbus ASCII and Plus. People who have worked can further elaborate on this thing, or you can YouTube on those things if you're working on those two. But yes, the generally used are RTU and TCP communication. How does a Modbus communicate? It is basically a communication between two controllers which acts as a master and another one acts as a slave, and there can be a number of slaves down the line. So if your controller is a master asking for certain data to this slave, this will be sending a request or a query to the slave, and the slave is going to give master a response of what the query was. That's how the communication is. Now, for any political reason, if you don't want to call this master and slave, I haven't encountered on that topic yet, but I know people have stopped the terminology master and slave due to all the political reasons happening. We can call this primary and secondary, but MSTP is our protocol, so master and slave it is for uh, the device communications. Now, we saw this controller being a master talking to this slave. Now, what happens between these two when it communicates? So, if you have a query coming from here and you want to bring it to this device, so you send it to the first device as a master, or the protocol analyzes that, oh, the slave is after another slave, so this becomes a master, sends it to this slave. Once this gets a request, this becomes a master and sends it to this slave, and vice versa. While responding, it goes the other way around. Now, you might ask, how does this know the packet sent or the query sent from this to this is not for this device and for this device? So the packet or the message packet or the query of what Modbus has is the device address, the function code, the register number, the register count, data, and a checksum. Now the device address is the device address you're addressing of what device or what sensor you want to talk to. Let's talk about the function code, register number, and the register count, data, and checksum later on in the next slide. So as you saw before, there was function code here, which is these codes, and all of these IO ranges, which can come to the register number and the register count, and what the data was, which is stored in one of these registers. So you have multiple holding register. So we mainly deal with holding register, input register, and read and write of these two registers. You can you have few points which you go with coils, but rest we usually would be dealing with holding and input registers for your integration and stuff. So the holding register, you see the function code 3. This is a standard for Modbus, and all the device address is 4001 to 5000. This is the usual device, the register counts, and this. So let's say 4001 holds a temperature value for you, and 4002 holds a humidity value for it. So your packet is going to say, I need data from device address 2 of function code 3 of register number 4003, and it can be multiple bits. It can be 32. If in that case this becomes a least significant bit and the high significant bit. So how many counts of these bits are, how many count of these registers are, and what is the data within that. All of this is sent as a query. Now, checksum is a usual term in communication while you are sending a query, but with the checksum, say let's say a checksum value is XX. You have sent it as XX. While the response comes back, how will your controller know? Let's say I'll show it to you. So if this is sending to this one as an XX, and meanwhile if somebody else responds to this controller, how will the controller know if the response was from this device or from some other device? So the checksum value is what says, I am sending you XX to this device, and for this device I'll be sending XY. If there is a checksum back in the response saying XX, this automatically knows it comes from this device and not from this device. That is how checksum works. So essentially this is what your message packet's going to be in Modbus. I hope I've covered all of what is required for our integration. I'll quickly show you a software which we use in the field. This is the most used software when it comes to Modbus. This is ModScan. You can have your connection of Modbus TCP, or you can connect directly with your 485 and converter to your laptop or anything. So you configure your baud rate, what is your parity, stop bits, and how is your flow control. More of this can be found out in your manuals or other videos in the YouTube. I'm gonna link a few in the description and give you pop out on the video itself. Go through those things if you're interested. So as I said, so you have coil, inputs, holding, and input register. So as you can see here, ModScan, if I go to coil register, you'll literally see what we saw here. Of the range 0001 to 1000 when you go to coil. If you go to holding register, you'll see 400. So this is from 4001 to 100. You can change the length from 100 to 1000. It will show you all those registers to what you actually want. If you want the specific address of it, you can put in here. You can put in the actual address. If it starts from there, let's say we want it from 4100, and you'll have it from here. So once you have the device connected, you will see the number of pulls, valid slave responses, all of this thing, and you'll see a live data coming in. Now, let's see how you integrate the device in Niagara. So I have my station. To open the station, the Workbench was open for this. So let me log into my station. First and foremost thing you do is add the driver. Now go to your palette. As you can see, so in Modbus, if you go to your palette, see you have Modbus sync driver, slave driver, TCP, and TCP slave driver. We are taking JACE and an RTU protocol to the JACE, so we're going to use Modbus async. Now when you add this driver here, usually if you're dealing with the JACE or other things, it is going to ask you for few modules which are required to this. If you go to your software manager here, this should list you all the Modbus async, core, slave, and TCP. All of this should be installed, or whichever you're working with async network right now. This should be installed before you can add the network there. So now that we have the Modbus async network created, the first and foremost thing you do in the network is to set up your network to basically communicate to the device. Now, what have we done? So this is saying no port selected for Modbus communication. We have connected our device to COM1. So this is saying do not enable because this is not a valid port. That is because this is case sensitive. So your COM1 is done. Now I'm gonna add this to 38400. That's my device baud rate, which I can get it from the spreadsheet or the device defaults, which you can find it on the web. Rest of all can be modified according to how your communication is set up with the flow control mode and everything else. Rest of everything can remain the same. You can save it, go back, And now we can add our device here. Modbus async. I'm gonna call in my device saying Modbus device 1. See, the device address default is 1. You can change that from here once you double click on that thing. You can override the network. You can change your float byte order to 1032 or 3210, which is you can make the least significant bit come on the left or least significant bit go on the right. So you can do vice versa. You can enable multiple coil, use force multiple coil, or use preset of multiple registers, which I'm going to show you what all of these things are. And the pink address of hex being 0, if I use this to decimal, this becomes 1. So all of this bare minimum has to be put in once you, if you have to establish the communication. Now if you go to your device here in the AX properties, you're going to see the base address of input registers, which you can add for the hex, in hex, or decimal, or in Modbus. So you can configure all of this for the Modbus configuration before adding the device, or while adding the device, or after adding the device. And now let's move on to adding points. So where do you get your points? How do you know what points to add? Because Modbus in Niagara doesn't give you a discovery option of bringing in all the points. So you have to open up your installation manual, which comes with the unit or the sensor or whatever you're using. So this one gives you what your default baud rate is going to be, what is your stop bit, how many bits of data it's going to be, what is the stop bit you're going to use, and what is the default of it, what would be the default parity of it, and the register maps of what the functional code for holding input or the write in multiple registers, which should be standard according to the Modbus communication. Now if you go down here, you can see Modbus register table showing you what the starting decimal numbers for a particular values are. Let's say we will be doing these 4 here right now, which is a temperature, humidity, CO2, and TVOC measurement. We will be doing this. So the addresses are 1004, 1006, 1008, 1010, which is all read and comes in a function code 4, which you can see 4 is read input registers, and these are all float big endians with 2 decimal, 2 decimal, 0 decimal, and 3 decimals. So let's see how to add these. So I'm gonna add 4 numeric points, not writable points, because this is read only. I'm gonna add 4 of these decimal, and I want to add it from 1004. Your data type's gonna be what it says as float, which you can select as float type. You can add these 4 here. Now, as you can see, once you have added 1004, it doesn't take 1005 as you have added as float. It considers 2 bits, and 4 and 5 are reserved for the float bit once you consider float. 1004 was temperature, so let's name this temp. Enabled, default policy of tuning, pole frequencies, normal, decimal, 1004. Register type is not holding, this is gotta be input, and this is floating type. Now device facets and your facets can be changed. Now what he says here is this is in degrees Celsius is what your sensor is going to be given. So what you do is go to device facet, configure this to temperature, Celsius, we want your precision to be 1, and likewise you're going to do temperature, but I need it in Fahrenheit. So this can calculate on itself and change and give it to you in Fahrenheit. The next thing, 1006, is humidity. Let's put it as humidity, numeric point, default, normal, decimal, not holding, input. So for this one, we're just going to do from miscellaneous, we're just going to do percent, and I don't need in decimals for humidity. What is 1008? CO2. Let's do CO2 1008 again, input, float type, device facets. This is a concentration which is parts per million. I don't need decimals. The next one is TVOC, which is the number of gas molecules and other things in your fresh air coming in. That is, I think, let's give this 3 decimal out there given, since this is very minute value and it should come in density if I'm not wrong, which is milligram per cubic meter. Yes. Alright, so these 4 values, if we add, now it starts communicating here. So you can see the temperature is 69.2 Fahrenheit. My humidity where my room right now is 48, which is very high, surprisingly. CO2 is about 1067 and my TVOC is absolute nil. So let's say you want to change this again back to Celsius. You can go back here to change it to Celsius and you'll see the actual value converted to Celsius again here. So just for time being right now, I'm just going to blow on the sensor real quick and then you should see a change in the CO2 value accordingly. There we go. That's my humidity changing and my CO2 should be changing real quick. Let me change this to Fahrenheit again. 69. See this thing going upwards. So that is how you add points onto your Modbus, and you can take these points, make it a new folder of individual devices and then start putting into your graphics and other things. Hope this video has taught you what you were looking for. I hope to see you guys back again for new stuff. Please drop down anything you want to see in the comment section, and I'll try to make new videos according to those. Alright, thanks for watching the video, guys. Hope you have liked it. As I say in every video, please drop your comments if you're looking out for specific content or any specific topic that you'd like me to make videos on. Keep encouraging. Please like, share, and subscribe. Look forward on you guys coming back to my channel and explore more videos. Thank you.